When I say heat, it is dependent on the mass of body. Okay. Then along with mass of body, it is also dependent on the temperature of body. Now you know how temperature is related with the heat. And then the third one is a specific heat capacity. Just rewind this lecture back in 5 minutes. So when I told you in the beginning, heat is what? It is the kinetic energy possessed by the molecule of a substance. Okay. So if a molecule, if it is more massive, definitely it will have more mass also. So if a body having higher mass, it will have naturally having higher heat energy. But that does not guarantee you a higher temperature. So the first factor, mass of body, means it has a positive correlation with heat energy, because I told you higher the mass, higher will be heat energy. When I say temperature, so it is the, what was it? It was the average kinetic energy of the substance. Okay. So in this case, if a body has higher temperature, means it has relatively higher heat energy. Then the third one is a specific heat capacity. So this is some physics term, but I will explain it for you. This is the amount of heat required. It is the amount of heat required to raise unit temperature of a unit mass of a body. Let's say if you have 1 gram of water, you require some heat energy to raise the temperature of 1 gram of water by 1 degree C. So the amount of energy which will be required here is known as a specific heat capacity. अभी आपको बता देता हूँ, in sense of water has probably highest of the heat, a specific heat capacity in among all these geological features. Okay. रॉक्स से, डिफरेंट काइंड ऑफ जियोमॉर्फिक फीचर से भी ज्यादा स्पेसिफिक हीट कैपेसिटी वाटर का होता है. ओके, सो ये हम लोग यूज करेंगे लेटर इन द क्लास. सो these are the three factors on which the heat energy of a body depends. First one is your mass, second one is temperature of body, and third one is your specific heat capacity. So you know that even a body, we will not say that heat energy and temperature are exactly the same. We will see this by one more example. So let's say you have a mug of boiling water. Okay, so this is your mug. So its average temperature is, if it is a boiling water, it is near 100 degrees C, and its mass is 250 gram. You can also write 250 ml or 250 gram in this case. Now I have a tub of water. This tub is also warm but not boiling. It has been boiling earlier but now not boiling. Now let's say its temperature is 75 degrees C. But its capacity is 25 liter. Okay, we have 25 liter of water in this tub and 250 gram of water in this mug, or at place of 25 liter, I can also write 25 kg in this case, because you know density of water is near 1. So I can convert this in between these two. So the thing is that if someone asks you if it is at 75 degrees C and if it is at 100 degrees C, so which one of them is hotter? Easy for you. It is the water in this mug. It is hotter. But it is the definition of temperature. It tells us about that how much body is hotter or colder. But it does not directly assimilate about the presence of heat energy. Okay. So in this case, you know it is hotter because it is of higher temperature. In this case, it is colder. Relatively colder in comparison to this one. But does it means that this one has a higher heat energy? No, because I told you in this last slide, along with the temperature of body, it is also mass of the body which determines the total heat of the that substance. Okay. Meanwhile, a specific heat capacity, तो वो तो दोनों के केस में सिमिलर है क्योंकि दोनों वाटर ही है, तो थर्ड को तो हटा देते हैं. But you know, it is much more massive in comparison to this one, and even temperature difference is of 25 degrees C, but its mass is so much more that it overcomes the difference of this temperature. So In terms of temperature, it is of higher temperature, but in terms of heat energy, it is of higher heat energy by virtue of mass. Okay. So even a body having lower temperature, if it is much more massive, it may have a higher heat energy. अब आपको दोनों का difference यहाँ पे थोड़ा clear हुआ होगा. Now we will use certain examples that where even if you are supplying or removing the heat, it might not lead to change in temperature. Okay.